So in this exam, we're given data on company fundamentals for the last 10 years. We have the ticker, calendar date, revenue, net income, market cap. We'll certainly need some packages, Tidyverse, Stargazer, Lubridate. Let's load in the company fundamentals data. Let's call it AF, so annual fundamentals. We'll do read CSV, and the name of the file is annual fundamentals.csv. Let's load that in. We've got 26,000 observations and 9 variables. And there it is. A ticker is a character, calendar date is a date, revenue is a number. This all looks pretty good. What are we supposed to do? How many observations? So that's basically a number of rows of AF that's going to show up to 26,000. 275. How many variables? 9? No. How many? Yeah, I think it's 9. 9 variables. What else? Number of distinct companies. So we can do n distinct of AF ticker. Ticker is an identifier of a company. We got about 4,397 companies. So it's really most of the stock market. And how many distinct dates? Let's do that as well. And distinct AF of calendar date, 9. So we have 9 years of data. Actually, it looks like 9 instead of 10. Let's take a look. If I sort it by calendar date, we start in December 31st, 2010, and we end in December 31st, 2018. Okay. Do all companies have the same number of years? Well, let's take a look. So we can start with AF. We can group it, group by ticker, and we can ask, can summarize by ticker and ask, well, how many observations we really have for each company. It's going to give us a lot. It's going to give us a big, well, let's actually make this a new data frame. So by company, or you know what, let's do it by ticker. If and what can we see? These are the 4,397 companies. Clearly, some of the companies are there for 9 years, like Apple is, but some of the companies are there for much fewer time periods. Okay, do all companies have their data for consecutive years, or do some companies have gaps in annual reporting? So this is a much more challenging question. How can we do that? So let's do this again by ticker. Let's overwrite that data frame, and we'll start with the annual fundamentals. So we'll group by ticker, and let's also arrange the data by ticker and calendar date. And then mutate. Let's see if there is a gap, if the consecutive years are really 1 year apart of consecutive dates. So we're sorting this data by ticker and calendar year, and then we're going to go down each ticker and ask ourselves whether the next observation is really just a 1 year ahead of the previous observation. So we're going to call this diff. That's going to be diff in about the year of calendar date. Remember, we saw this year function earlier. That's part of the lubridate function. And year minus year of a lagged calendar date is going to give us the difference. So let's see what that is going to look like. So by ticker. So we didn't really summarize this, but we have the data sorted by ticker and calendar date, and we can clearly see, well, there's NA in the first observation. That's not surprising, but then we have 1, 1, 1, 1, because those are all consecutive. These are all looking consecutive. Oh, well, there's one that's not right. We have a observation for 2010, and then next observation for 2015. So there are definitely some gaps here. Okay. Can we identify, can we sort of limit this to companies that have gaps? Let's do that. Let's filter based on, we really only want companies where the maximum value of the difference, ignoring NA remove is true. So ignoring the NAs. Where the maximum is greater than 1. Because if there's a company like this one here, like the first one, where the maximum is 1, then that means that for that company, all the differences between consecutive dates were 1. And so we don't want that company. We want to identify companies that have maximum difference that's greater than 1. So let's see what that will look like. And that clearly is only a much smaller number of companies. Let's take a look. It's this company, ACHN. Clearly, we have them for 2010, 2011, 2012, and then gap, and it appears in 2015. Fantastic. How many companies have these gaps in data? Well, it's easy to do. We can just do n distinct of by ticker. 137 companies have gaps. All right, the company info.csv contains information on each company, their sector, company name, and other things. So let's call it CI for company info. We're going to read CSV, and it's called company info.csv. Let's see, that's 13,000 observations. So we got the ticker, the name, the exchange, sector, industry, lots and lots of different companies. All right. Join the ticker data with the fundamentals data. What type of join do you think would be appropriate? So, well, clearly we've got more companies in the company info data than we have in the ticker. Than we have in the annual fundamentals data, because in the annual fundamentals, we have just 4,300 companies, but in the company info, we have 13,000 companies. What type of join is appropriate probably depends on what we want to do, whether we are interested in analyzing the fundamentals. If we're interested in analyzing the fundamentals, then we probably want to keep only companies for which we have the fundamentals data. And so let's do that. And for that, we will left join the company info with the annual fundamentals, with the annual fundamentals being on the left. And so we're going to keep all the observations that we have for the annual fundamentals data, and where we have a match in the company info. Hopefully most of those companies will have a match. We will join the company info. So let's do annual fundamentals. Let's override it. Let's do left join with annual fundamentals is join with CI by, and I think ticker is the name, lowercase, in both data sets. let's run that. Did we lose any observations? So we actually didn't even lose any observations from annual fundamentals, which we wouldn't if since we used left join. Let's see if inner join makes a difference. If we did inner join, that means we would keep only data that have information both on annual fundamentals and the company info, like the name and the sector. And that doesn't change, which means that for all the tickers that are in the annual fundamentals data, we have information on their name and sector in the company information data. So we can keep it as a left join or inner join, same result. How many companies are there on average in each sector? All right, so by sector, well, by sector, and we're going to start with the annual fundamentals that now has a sector information. And we're supposed to calculate the number of companies in each sector in each year. So let's group by sector. And, oh, darn. Oh, I know what happened. I joined the annual fundamentals twice. So let me actually overwrite annual fundamentals here so that I don't have the sector X and sector Y there. And I can group by sector and calendar date. And I can summarize. And I will just do number of companies. That just would be n, because on each date, each row is a company, and in each calendar date, each company appears only once. So let's see what that looks like. So by sector. So this is really by sector and date. Basic materials. In 2010, we have 245 companies and 238 and so on. Communication services is much less. Very good. So all we now need to do is to average these numbers within each sector across all of the years. So let's do that. So we're going to group by calendar date, and we will summarize. So we are now looking for average. So average number of companies equals mean of number of companies. Fantastic. And so now the data set indeed is by sector. We've got 9 different, what did I do? I grouped it by calendar date. That's not what I meant. I want to group it by sector. And I have 7 different sectors. And the average number of companies in basic materials is 229. In technology, it's 696 and so on. So this is very good. Let me just do by sector here so that it then shows up in the knitted document, so that that table it appears. Okay, list top two companies by revenue in each sector in 2018. Show each company's revenue share in its sector. Okay. So let's do this. List the top 2 companies. So we'll need to have a table that has basically 2 rows for each sector. So it's going to be 14 rows. So let's call it by sector top 2. we'll start with AF, and we're gonna group. Well, first we need to filter. So we need the calendar date, or the year of the calendar date, to be equal to 2018. So we limit ourselves to just 2018. Now let's group by sector. And we will need to calculate total revenue by sector. So it's going to be sum of revenue. Let's just check it out. So, oops. Sector. So by sector top 2. So yeah, so we have just 2018 data, and if we sort this by sector, the total revenue in that sector is this humongous number. Here are all the companies in that sector. Then when we move to the next sector, it's going to be a different number, and so on. But we've got each company's revenue here as well, so we could calculate that company's share in the total sector revenue. So share revenue is going to be revenue divided by total revenue. That's not bad. And but we now want to show this for only top 2 companies. So let's create a rank within each sector. Yeah, because we're grouped by sector. So it's going to be a rank by revenue. It's going to give us 1 for the company with the lowest revenue. So we need to flip the sign so that number 1 is a company with the highest revenue. Okay, so let's actually check this out. Yeah, just so that it's easy to view. Let's arrange by sector and revenue, so that we have the, how about this, in descending order. So here is the basic materials sector. DuPont is the company with the highest revenue. Very nice. The total revenue in that sector is this humongous number. DuPont has a 13% share. And it's got a 13% share. It's ranked number 1. Number 2 is Lyondell Basel Industries. Never heard of them. Nucor I've heard of, but they've got 5%. They're ranked number 2. So we're going to take just the top 2 companies. So we'll need to filter. We'll filter. The rank has to be less than 3. And if we do that, we've got a data frame with just 14 observations for each industry. We've got the top 2 companies and their revenue share. Let's make this table also a little simpler by doing select. I'm going to select sector. Let's select the name of the company. Do we have a name? Yes. Sure, we can do ticker and name and share of revenue, and I'll run that, and let's display this by sector top 2. Oh yeah, that's a pretty nice table. Okay, in technology, Apple and Amazon are the top 2 companies. In industrial, it's a GE. I don't think that's true anymore. And Boeing is number 2. Okay, fantastic. Plot the revenue share of top 3 companies in each sector from 2010 to 2018. One line for each sector. So we're plotting. So we need to prep the data set for that first. What does the plot tell you about the trend in market concentration? So we're going to adopt actually this code. So I'm going to copy that. But in this case, we're not looking at just 2018. We want to look at the entire time period. So we're going to group by sector and calendar date. Now within each sector and calendar date, we're going to calculate the total revenue and the share of revenue and the rank. And this time we're going to keep top 3 companies. So the rank has to be less than 4. And let's see where that takes us. I don't think we don't need to really arrange this, but let's do it just so that we can see where we are. Calendar date, sector, and so on. And I'm going to leave it like this. Let's run this. Oh, I overwrote the top 2. I should have called it top 3. So let's do that. Top 3, what does it look like? We've got there, or in 2010, the companies, let's see, how do we have this arranged? By calendar date, sector, and descending revenue. All right, so these are the top 3 companies in basic materials. These are their shares. So DuPont's share actually in 2010 was only 10%. That's interesting. And so we actually want to then add the share of the top 3 companies. So we need to then group by basic materials, group by sector and year, and add up these shares so that we see what is the share of the top 3 companies in each sector in each year. Let's do that. So we will group by, well, we actually already have it grouped by sector and calendar date, so we don't need to do it again. We just need to summarize. And we will be calculating share of top 3 is going to be sum of share of revenue. How's that? So now we've got 63 observations. We've got each sector there 9 times, and this number tells us what is the share of revenue of the top 3 companies. Fantastic. Now we can plot this. ggplot by sector top 3. The AES function has, well, on x-axis we want calendar date. On a y-axis we want share of top 3 companies. And since we want to have a separate line for each sector, we're going to map a color to sector, and the geometric object geom is going to be line. Let's do that. All right, fantastic. And we see very clearly that for most of these sectors, the share of top 3 companies has gone up. So the concentration has gone up in most sectors. I guess the exception is industrials. Okay, fantastic. Now, file S&P 500 constituents has information on which companies belong to the S&P 500 index as of 2019. It also includes information on when various companies were added or removed from the index. Using the fundamentals data as of 2018, what would you say are the key differences between current S&P 500 constituents and the companies that are not included in the index? All right, so let's load in that S&P 500 constituents data. So let's call it SP read underscore CSV and SP 500 constituents dot CSV. Let's see what it looks like. Here are the current members of the S&P 500, ServiceNow, Las Vegas Sands, and so on. And it has also information on companies that were added or removed previously. So let's just keep the information on the current, let's just keep in the data tickers of the current S&P 500 constituents. So we'll filter, and action has to equal current. So that has 504 observations, 500 constituents in the S&P 500. Oh, now we have to show if companies in our annual fundamentals data are different from companies that are in the S&P 500, how they are different from companies that are not in the S&P 500. So our annual fundamental data does not have that information. So we need to join the S&P 500 information with our annual fundamentals. We have a ticker, so that should be pretty easy. And we should be able to identify companies that match in those 2 data sets. And those would be the companies that are current constituents, and companies that do not match are the ones that currently are not in the S&P 500, which is the majority of companies, because we have 4,000 companies and only 500 of them are members of the S&P 500. So let's call this annual fundamentals S&P data frame, and we'll do a left join between annual fundamentals and S&P by ticker. That's easy enough. And that, well, actually, we're supposed to look at only companies in 2018. So let's do, that's fine. Actually, we can do that here. We can filter year of calendar date, calendar date has to be equal to 2018. Okay, so that's 2,700 observations. That makes sense. And by 2018, we only have 2,700 companies. Overall span of 10 years, we have 4,300 companies, but in 2010, it's only 2,700 companies because companies go in and out over that 10-year period. So can we identify which companies were our current members? Well, there's this action column, which comes from the S&P 500 constituent data frame. It says current if there was a match, and it's an NA if there was not a match. So Giant Technologies is a member of the S&P 500. What's this company? This company, Alcoa. Alcoa is, wow, is no longer member of the S&P 500? I guess not. So it's not. So let's create that variable that's going to flag each company as a member of the S&P 500 or not. If else, so we'll call that variable S&P 500. And it's going to be based on whether or not action is missing. If action is missing, then the company is not a member of the S&P 500. If it's not missing, it will say current, and the company is a member of the S&P 500. Fantastic. Let's see how those companies differ. So let's use Stargazer of as data frame. We'll use a filter of AFSP, and we're going to use SP 500 equals 1. And type equals text. There we go. These are the descriptive statistics of the 333. So we only had 333 companies in our data set that are members of the S&P 500. Clearly, our fundamentals data set does not have all of the S&P 500 companies, which is somewhat surprising, but that's what the data is telling us. The average revenue of companies in the S&P 500, what are we talking about? This is 26 billion. Average market cap, 53 billion. Let's do the same thing for companies that are not in the S&P 500. It's going to be the majority of companies, 2,400 companies. Average revenue about 1 billion. Average market cap about 1.8 billion. Clearly, the companies that are not in the S&P 500 are much smaller. Estimate a logistic model of determinants of current S&P 500 membership using the 2018 net income, market cap, and exchange. So the S&P 5. Well, so we also have information of where the company is traded. Comment on your results, including the magnitude of the effects. So I'm going to create a model using the GLM, generalized linear model. The dependent variable is SP 500, and we're going to regress that on net income. And did we say market cap? Yes, market cap and exchange using data AFSP. I think it's the function equals binomial. Oh, actually, it's a model. I think it's model. Model is binomial. Oh, we did something wrong. Oh, family is a binomial. Family is a binomial. Let's look at the summary of the model, and let's look at the exponential of the coefficients of the model. All right, so net income affects the probability of being included in the S&P 500 positively in a statistically significant manner. So does market cap. So does the fact that you are traded on the New York Stock Exchange, as opposed to, I think, NASDAQ is the left out or the reference category. Okay, the magnitude of the coefficient. Net income doesn't actually seem to affect. The magnitude of that coefficient is basically 1, so it doesn't really change the odds of being included in the S&P 500. Neither does market cap. Partly these are because really $1 increase in market cap is a tiny amount. If we change the units, if we measure the market cap in billions or net income in millions or billions, we would see some effects, but changing market cap by $1 doesn't really affect the outcome. It's just too small of a change. The exchange, the New York Stock Exchange, increases the odds by a factor of 2.7. So that's basically 170% increase in the likelihood, in the odds of being included in the S&P 500. Finally, using the above model, what are the probabilities that Apple, Albany International, and Dave & Buster's are included in the S&P 500? Let's create a test data frame, which is going to start with AFSP, and we're going to filter. So we're going to filter, and ticker has to equal AP. Oh, it's actually APL is for Apple. Ticker, and the ticker for Albany International. Or ticker equals AIN. That's the ticker for Albany International. How do I know that? I'll show you in a minute. And ticker for Dave & Buster's is play. And how do I know that? Because if I go here and I look for Apple, I see Apple. There's the ticker AAPL. Albany International is AIN. Fantastic. So let's do that quick. In the test data set, did something wrong. Again, something wrong. I need 2 equal signs here. Test should have just 3 observations. Fantastic. So we will make predictions using function predict. We're predicting using model M and using test data. And actually, we need to specify the response. I think it's called a type equals response, so that it gives us probabilities. Okay, the probability that Apple is included in the S&P 500 is 1. That AIN, Albany International, is about 5%, and Dave and Buster's really 1.5%, so much lower. Okay, excellent. So this is a really long and challenging exam. I'm going to stop recording here. Again, I encourage you to look at the typed up answers in the PDFs, and I will stop here.